Hey, Global Impact students, this is Mr. Ellinger. This lesson is on writing a function rule. Our learning target for the lesson is we want to be able to write equations that represent functions. Some essential understanding for you for the lesson. Many real-world functional relationships can be represented by equations. Equations can be used to find the solution of given real-world problems. Some background for the lesson. When we write a rule for a table of values, we must make sure that the apparent pattern does indeed hold true for each pair of points listed in the table. While 2 points are enough to determine a line, at least a third point should be used as a check to find and correct errors in calculation. Using algebra to solve real-world problems involves two major steps. The first step is to model the real-world situation with an algebraic function or equation. The second step is to either evaluate the function or solve the equation. This lesson provides an in-depth look at writing an algebraic function to model a real-world situation. Okay, so many real-world functional relationships can be represented by equations. You can use an equation to find the solution of a given real-world problem. So here's an example. You can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees Fahrenheit more than 1/4 the number of chirps the cricket makes in 1 minute. What is a function rule that represents this situation? So, a lot of times when we have a word problem like this, a real world problem where we're given the problem situation as a paragraph or whatever, we need to identify where is the math in the problem. And this is the tricky part. And really, the math part of this problem comes in this sentence right here. So we have to be able to translate that sentence into some useful mathematical equation or function. So it says the outdoor temperature is about 40 degrees more than, so there's an addition. 40 more than means something plus 40. 1/4 the number of chirps the cricket makes in 1 minute. So if you think about that sentence as a whole, the relationship that's taking place in that sentence, and this is the whole key, is first of all, understanding the relationship. A lot of times we want to jump right to the equation. We want to write it down and we want to go. We need to think about the relationship. What is being said about the relationship here? The relationship is between temperature and the number of chirps a cricket makes. So the relationship would be that the temperature is 40 degrees Fahrenheit more than 1/4 of the number of chirps in 1 minute. And you can see here in my relate here, we've got kind of a blue box around temperature, a yellow box around 40 degrees Fahrenheit, purple around 1/4, and then yellow around the number of chirps in 1 minute. Those are the mathematical parts of this. Now we have the word is and we have the word more than. So those are operational tools or relational tools. Is means equal, more than means add. So, as always, when we're doing a problem like this, we've got to define some variables. So our two variables in this problem are the temperature and the number of chirps in 1 minute. So we'll let capital T equal the temperature, and we'll let N equal the number of chirps in 1 minute. So once we determine the relationship, we define our variables, then we can write our equation or our function. Okay, so the equation would be capital T equals 40 plus 1/4 times N. And you can see here what we did was we just had the relationship in words. We took out the word temperature, put in a capital T. Took out the word is, put an equal sign. 40 degrees Fahrenheit is just the number 40. More than is an addition. 1/4, the number 1/4. Of usually means multiplication. And the number of chirps in 1 minute, that's our variable N. So you can see every part of this relational statement is translated into a mathematical equation, or in this case, what we call a function rule. Okay, so a function rule, we have capital T, remember that's our dependent variable. It's by itself over here on the left side of the equal sign. Everything else is on the right side of the equal sign. So our equation would be capital T equals 40 plus 1/4 N. And then once we get that equation or that function rule, we can do lots of other things with it. Okay, so another example here. Let's see if we can do this one. A landfill has 50,000 tons of waste in it. Each month, it accumulates an average of 420 more tons of waste. What is a function rule that represents the total amount of waste after m months? So the relationship here is we have time, okay? So we have time in months. And the relationship is what? As time passes or time increases, what happens to the amount of waste in the landfill? Well, the waste increases. Okay. So there's our relationship. Now, if we want to define some variables, our two variables are the amount of waste and the time. So we're actually told here that we're going to let m equal months. So time equals months. So we'll let m equal the months. And we'll just go ahead and let W, capital W, equal the waste. Okay. So here's where we need to translate this into an equation. The amount of waste Okay, so the amount of waste in this landfill is 50,000 tons plus an additional 420 tons per month. So, here again, we've got to kind of take this sentence and pick it apart here. This part is our variable W is an equal sign. Here we have 50,000, which we'll use, plus an additional means add. 420 tons per means multiply for 420 per month. So if we take all this and formalize it into an equation, we get capital W equals 50,000 plus 420m. And notice we don't put units in an equation. We leave the units out. We just put the numbers in, and we can always go back and add our units onto our answer if we were going to do a calculation using this equation. Okay, so here's another example dealing with concert revenue. A concert seating plan is shown below. Reserve seating is sold out. Total revenue from ticket sales will depend on the number of general seating tickets sold. Write a function rule to represent this situation. What is the maximum possible total revenue? So you can see we've got the stage, and then this maroon colored seating area is our reserve seating, and then this yellow or gold colored area of the arena is where our general seating is. So we're told that reserve seating is $25, 10 rows, 12 seats per row. Our general seating is $10, 30 rows at 16 seats per row. So the relationship here is that the total revenue, okay, how much money they bring in, is general seating revenue. So it's the price per ticket times the number of tickets sold. That's how we would get the total revenue for general seating plus the reserve seating revenue. So we're going to let capital R equal the total revenue. We're going to let N equal the number of general seating tickets sold. And basically we're just, after we define our variables, we take our relate statement and write our equation. So capital R equals 10 times N. Okay, that's $10 per number of tickets sold for general seating, plus 25 times 10 times 12. Now where that comes from is the fact that we are told up here that reserve seating is $25 per seat. There are 10 rows of seats, 12 seats per row. So it's $25 per 10 rows of 10 seats. So 25 times 10 times 12. So, just to kind of simplify that and consolidate it or whatever, we get R equals 10N plus 3,000. That's the equation for the revenue in this problem. So, for instance, if this place were to sell one general seating ticket, which I'm sure they probably wouldn't, but if N was 1, then their revenue would be 3,000 plus 10. Okay, so the number of general seating tickets sold times 10 plus 3,000 would be their revenue. So the function rule capital R equals 10N plus 3,000 represents the situation. There are 30 times 16 equals 480 general seating tickets. Okay, and again, that goes back up here, 30 rows of 16 seats per row. So if we substitute 480 in for N, we're going to find the maximum possible revenue because they ask us to do that. So if this place was sold out totally full, N would be 480 because there are 480 of those tickets. So if we multiply 10 times 480, we get 4,800. Take that and add it to 3,000, we get 7,800. So the maximum possible revenue from ticket sales is $7,800. Okay, so here's another problem. A kennel charges $15 per day to board dogs. Upon arrival, each dog must have a flea bath that costs $12. Write a function rule for the total cost for n days of boarding plus a bath. How much does a 10-day stay cost? Okay, so our two variables in this equation are the cost, okay, so total cost, and the number of days. And the relationship here is that no matter how long your dog stays at this kennel, it's $15 every day, okay? So the cost is $15 per day plus a flea bath when they arrive. Okay, so that's a statement that says, the situation here. So if our total cost, let's let that be capital C, the number of days, we're told to let that be N. So again, we just have to basically translate our relate statement that shows the relationship between the two variables. We have to translate that into a mathematical equation or function rule. So capital C equals 15 per day, that's per N, so times N, plus the amount of the flea bath, which is $12. So, again, this equation shows the relationship here. For every day, you're going to keep adding $15, right, for the stay. You know it's going to cost you $12 no matter what. So even for a one-day stay, it's going to cost you 15 plus 12. All right, and then each additional day, you're going to keep adding 15. So 15 per day. Instead of adding 15 every time, we just multiply 15 times the number of days, and that gets us our cost. So there is our equation. So it says, how much does a 10-day stay cost? Well, the second part of this is they're saying, let n equal 10. And let's go ahead and evaluate this function. So C, the function would actually be C of n. Okay, the function would be the cost function, and our independent variable is n. So they're asking us, what is C of 10? Well, C of 10 is going to equal 15 times 10 plus 12, which is 150 plus 12, which is $162. So the 10-day stay is going to cost $162. Now, this is the math that I use to solve this, but what I should always do anytime I'm asked a problem like this, a real-world type of problem where I'm asked a question, I should go ahead and answer the question with a sentence. So I would say a 10-day stay. So a 10-day stay will cost $162. This is the answer to the problem. Okay, right here. This is not the answer to the problem. All right, so we have to address the problem. This is where we can incorporate our units and answer the question in an appropriate way. Okay, so here's a second part of this. Does a 5-day stay cost half as much as a 10-day stay? Well, how would we figure that out? Well, if a 10-day stay costs $162, what do we need to figure out? We just need to figure out what is C of 5, a 5-day stay. So that would be 15 times 5 plus 12. 15 times 5 is 75, plus 12 is 87. So is 87 half of 162? So 87 times 2 is 174. So 87 is not half of 162. So what's going on here? Well, if we look at our cost for 5 days, just the amount per day, 75, is half of the amount for 10 days. So that is half. But no matter how many days we stay, we have this additional $12. So there's always going to be a difference there. It's not always going to be just half because you always have that $12 amount. So the cost per day, just that part, is half for 5 days versus 10 days. But when you throw the $12 in, it doesn't work out to be half. So that's how you would answer part B. All right. So, this lesson right here is a big, big key. A lot of times we don't like to do the problems where we have to actually take the words and translate it into mathematical equations or functions, but we can do it. We just have to have a method that we go about doing it. So we look for the relationship first in the problem, assign our variables, and once we get that stuff done, then we can write the equation, and then we can start using the equation. So big key here. Again, we can do this. We just have to have a method. So here's the method. Let's do it. I will see you guys next time.